All right, in this one, we're going over A.9C where we're going to write the exponential functions. So what I need to do is look at my y-intercept. My y-intercept is always going to be related to my initial value. So that's 6%, 6, 6. And so I'm going to look at my answer choices. Okay, each one of these has 6. That's correct. But C has subtract 6 minus, it's going to be 6 times whatever our B value is to the x power. So C is not in the form of A B to the power of x. That is C, that would be A minus B to the power of x, and that's not our format. Same with D. Okay, so D can't be it. All right, now the difference between A and B, A is decay, B is growth. My function is going up from up to down. It's going in this direction. So it's not increasing, it's decreasing. So this is decay. So our answer is A. All right, function represents the same relationship. I'm going to identify my y-intercept, which is when x is equal to 0. That's going to be right there at 18. So that eliminates C and A. All right, now I need to figure out whether or not I have growth or decay. There's a couple ways that I can go about doing this. Exponential functions do not have a consistent rate of change. Now, if we look at our format, which is A times B to the power of x, this is the same thing as A sub 1 times our rate to the n minus 1, meaning this is a geometric formula. So what that means is I can look at my terms, and I'm specifically going to look at my y terms, and I'm going to divide them. So I'm going to take the second term, 25.92, and divide it by the term prior, which is 21.6. Now that gives me 1.2, which gives me 6 over 5. So you're going to get your rate, your R value, which is B. Again, you're going to take your second term and you're going to divide it by your first term, and that will give you your rate. Okay, this is which is equal to your B value in your exponential function. We're dealing with the same function. Yep. Okay, had to make sure we were on the same function. There are 124 players in the tennis tournament. Each round, half the players are eliminated. Okay, each one of these has an A value of 124. Now, if we're talking about elimination, that means we are decreasing. So A is an increasing, C is an increasing. Now, we've got the difference between 0.5 and 0.05. Okay, well, let's talk about 0.05, half, okay, as a percentage. So half would be 0.5 divided by 100. That would give me, 0.5 would be B. Sorry, I'm overthinking this one. Because 0.5 is a half, so that would be 0.5 in terms for our B value. There we go. Same teak. Okay, so we're going to, now look, we're talking about exponential functions. I'm going to eliminate C and D because those are not set up as exponential functions. In the year 1900, the total number of metric tons of the products was 495,000. Both of these have that same initial A value. Each year, the total number of metric tons produced is increased on an average. A is an increase, B is a decrease, so our answer is A. That's it. That's all we have to do. We don't even have to do any calculations. All right, we're going to do the same setup with 15. A particular type of cell doubles in number every hour. So if we're doubling every hour, we are getting larger. Okay, now we're going to eliminate C and we're going to eliminate D because those are not in exponential format. Okay, now which function can be used to find the number of cells present at the end of H hours when there are initially 4 cells? So that means our A value is 4. If we're getting larger, we're doubling every hour, then 1/2 means we have decay. So that would be decaying by hours, that'd be decreasing. D has 2, so that's greater than 1. That means we have growth, so our answer is B. All right, same teak. We're going to handle it the same way that we did the other ones. Fertilizer and landscaping company decreases. So I'm going to eliminate all my ones that have an A value greater than 1. So A or B value, that's A. That's B. Oh, look, that's D. Oh, look. Oh, we don't even have to do any further. Our answer is C. We don't because this is decreasing. A and B have an A value or a B value greater than 1. So that they're out, and so does D. All right, a toy is made up of cylindrical stacks based shown on the diagram. Now, the diameter is 1 and 87% of the diameter of the base. The rings 2 through 7, diameter of each base is 87%. Okay, so as we're going from our base up, the diameter is getting smaller. Okay, now I can eliminate G and I can eliminate J because they are not in, well, hold on, let me take that back. I need to take that back. Yes, no, I can cross this out. Yes, they're not in exponential function format. They're not in the a b to the power of x. The r is r minus a number, so G and J, we can eliminate this. Now, if I'm looking at this, my base, from my base as I'm going up, getting in the cylinders, they're getting smaller. My diameter is getting smaller as I'm increasing or stacking up. So that means if I'm getting smaller, that means we're decreasing in size. So that means my B value, the number inside the parentheses that the exponent R belongs to, needs to be smaller. So that gives me the answer F versus the answer H. H would be the other direction. All right, we are going to write the function, same relationship. I'm going to identify my y-intercept. So that answers my question right here. My A value is 0.0625, that's 0.0265, so my answer is H. It's that easy, you don't even need to go further. All right, the next question is a new teak, so we will go over that in the next video. I will see you later.